So today we're just going to go through the titration and gravimetric analysis examples. Actually, they are both fairly simple once you just understand exactly what we're doing, and it's all just basically just stoichiometry. So we'll just go through these pretty quickly. So this, again, should be a fairly short video. All right, so again, just going off the example from the slide. So in this example, we're titrating 30 milliliters of unknown concentration of hydrochloric acid. And we're using here 0.23 molar sodium hydroxide, and it takes 42.1 milliliters of this to completely neutralize the hydrochloric acid. So before we start, we just want to write down the equation, what is actually happening, just to make sure that we have all our stoichiometric ratios correct. So we've seen this reaction before. Hydrochloric plus sodium hydroxide give us water and sodium chloride. And what we're basically doing is we just need to find out, how much of these things we're actually putting in here. So again, we'll just write down our information that we have. So all we're doing is we're just trying to find this value. Okay, so essentially what we're doing is using our little stoichiometric flowchart here is we're starting from the volume of the solution. And the solution is going to be, of course, the sodium hydroxide solution that we have. We convert that to liters, use our molarity value that we have, use our stoichiometric ratio, which is just going to be 1:1 in this case. And then at the very end, we want to find the molarity of solution B, which is our hydrochloric acid. So we're just going to go through here and divide by that molarity. So first up, we just take our volume here and multiply it by my molarity. Convert this, of course, always to liters. And at this point, you might just want to write down, because of course we're going to be dealing with liters and milliliters on both sides here. So you might just want to just pencil in that, this is the milliliters of the sodium hydroxide that we're actually dealing with, just so there's no confusion with these values here. And of course, all this stuff here is going to be NaOH as well. All right, then we just do our stoichiometric ratio. And actually, we did see this one in the previous video. We had the moles here, and then of course we had our milliliters, and we just divided by that to make that work. Again, this is shown directly here. You divide by 1 over the volume in liters. And down here, of course, this is going to be the milliliters of the HCl. Just to, again, keep track of, milliliters of HCl versus milliliters of the sodium hydroxide. So once we do all of this, notice my milliliters of sodium hydroxide go away, my liters of sodium hydroxide go away, my moles of sodium hydroxide go away, and I'm left here, again, my milliliters of HCl go away, and I'm left here with moles of HCl per liter of HCl. And that's going to be my molarity, which I'm actually looking for. And once you go through all the math and calculate that out, this winds up to be 0.32 molar HCl. So what we've done is we've titrated with a 0.23 molar sodium hydroxide solution. It took this much, and we wound up with a 0.32 molar solution of HCl. So that's how we can verify titrations and know what the concentration of an unknown actually is. All right, so then for the final little thing here, we'll just look at the gravimetric analysis. So if you're wondering, this is like the pickle crisp and stuff that they actually have there. So you can see the pickle crisp, and this is basically just calcium chloride, food grade, so you don't want to just use laboratory grade stuff for this. But of course, if you're getting something else, it might, with the spices and everything included, they already have the pickle crisp. And you can actually see, if you look on the label here, for the ingredients, so you can see that where it says there, calcium chloride for crispiness. Okay, and that's what they're referring to as, for nice crispy pickles. And apparently this is expired, so oops. So we'll take basically 100 milligrams of this pickle crisp stuff, titrate it with some silver nitrate, and then weigh out the precipitate and use that to determine, how much, calcium chloride was actually in my original sample here. So the equation that we're going to be having here is, so that's my pickle crisp. All right, and just to, again, this is where the solubility tables come in quite handy. Although, first of all, we definitely need to make sure this is balanced, which it's not, because calcium is +2, silver is +1. So that means I'm going to actually need 2 silvers in here, 2 silver nitrates and 2 silver chlorides. And now everything is nicely balanced. And then just to go through our solubility things, the calcium chloride, all these are going to be nice and soluble. Silver nitrate, all nitrates are soluble here. That's aqueous. Silver chloride, remember the silver chlorides, these are the things that are actually going to be precipitating. And again, all nitrates here are going to be soluble. So if we just were interested in what our net ionic reaction would be, we would be taking here our 2 chlorides. Okay, so that would be like our net ionic reaction if we were actually interested in this. So what our problem sets up here is that we're going to have 100 milligrams of my pickle crisp. And one thing we do need there is the molecular weights. Since we have weight here, we need the molecular weight to convert this to grams. So calcium is 40, chlorine is 35.5. You do the math on that, and this turns out to be 111.0 grams per mole. So that's my molecular weight of my calcium chloride. And then for my silver chloride over here, this is, well, we're going to get 250 milligrams precipitate. So in other words, this is what we get at the end of the experiment. And our molecular weight of the silver chloride is 143.3 grams per mole. Okay. So again, here's the silver, 107.9, and the chlorine is 35.5. So when you add that up, it's 143.3. If you just went to 143, I'd be happy with that. And now, as for the concentration of my silver nitrate and how much we actually put in there, that doesn't matter, because the whole reason that we're doing this gravimetric analysis is because no matter how good we are, we're always going to over-titrate, just based upon the indicator that we're actually using. So basically all we're really caring about is the amount of calcium chloride that we're starting with, or potentially calcium chloride, and how much silver chloride we're actually getting off of this. So anyway, we'll just calculate how much silver chloride this calcium chloride here should produce, and then we can find out how that actually compares to our actually measured value. All right, so at this point, all we've done is just figure out for 100 milligrams how many moles that actually is, and then at this point we go here and calculate our mole ratio. So there's 2 silver chlorides per calcium chloride. Then we multiply by my molecular weight, which is 143.3. And then we just need to convert this into milligrams so we can do a nice one-to-one comparison. And again, knowing that everything cancels, my milligrams calcium chloride go away, my grams of calcium chloride go away, moles of calcium chloride go away, moles of silver chloride go away, and then we're just going to be left here with my milligrams of my silver chloride over here. So you can run through the math on this, and we wind up with 258 milligrams of the silver chloride, and this is my theoretical. So theoretically, if this was 100% pure calcium chloride, you would get 258 milligrams of silver chloride. Here in the problem, we get 250 milligrams. Is that a significant difference? Well, that all depends on your lab technique and everything. And it's possible that when you were doing the experiment, some could have just got stuck in the filter, or because of the finite solubility, some actually goes through. There's many other techniques you can go through to prove this or not. We can basically say here, if we just look at the percentage, remember our percent yields. Well, this would be 250 over 258 times the 100%, of course, and that's going to give us like a 97% yield. So and this is not actually an experiment that I did with my particular pickle crisp. I just used some numbers, but essentially a 97% yield. So either this stuff is 97% pure, or along the way we may have just lost 3% during the actual precipitation and whatever. So anyway, that's the gist of it. Fairly trivial kind of things once you get the hang of it. But again, really all the stuff that we were doing with the stoichiometry, reference yield flowchart, help follow along exactly where we're going with these paths, and hopefully this will make things much easier. Okay, so I will end it here and put this video together again. Yay.